Hello guys, welcome to this mathematics tutorial. So today we're going to be talking about approximate numbers. And approximate numbers involve you approximating a number so that the number will be able to make meaning and to shorten that number. So for example, you may have a very long number as 3.00758. This is long. Now I want to approximate this number. So there are two ways that we can approximate numbers. Number one is the significant figure. Number two is using decimal point. Now, the decimal system. So we're going to be talking about the significant figure, way of approximating number. So let's talk about the significant figure. Now, the significant figure has a set of rules that we need to follow in order for us to be able to approximate numbers. And I'm going to be stating the rules here for us to be able to know. Number one, if the number you are about to discard, is 5 or greater than 5, then you will increase the previous number by 1. That's number one rule. If the number you're about to discard is 5 or greater than 5, you will increase the previous number by 1. Now, if the number is less than 5, then you don't need to do anything. You leave the previous number like that. Leave the previous number the same way. So if the number is less than 5, you leave the previous number the same way. So if the number is greater than 5, you will increase the previous number by 1. Now, the second rule, another rules to follow. Every non-zero number is a significant figure. Every non-zero number is a significant figure. That's number one. Number two, every zeros in between two numbers is a significant figure. Every zero in between two non-zero numbers is a significant figure. Every zeros in between two non-zero numbers is a significant figure. Then the third rule, if there are no decimal points after the zero, then the zero is non-significant. If there are no zeros after if there are no zeros after the if there are no decimal points after the zeros, then the zero is non-significant. If there are no decimal points after the zeros, if there are no decimal point after the zeros, then the zero is not significant. Then the zero is non-significant. Then the fourth rule: every leading zero are never significant. Every leading zeros are never significant. The first rule. Now we have this: if the number that is about to be discarded is 5 or greater than 5, then you will increase the previous number by 1. Second rule: if the number that you're about to discard is less than 5, leave the previous number the same way. Then these are the rules that you need to follow. Why with the rules that you need to follow with this? Now, every non-zero number is a significant figure. So for example, now this, we can say 257 is a significant figure. So every non-zero number is a significant figure. 257 is a significant figure. Any zero in between two non-zero numbers is a significant figure. So you can have 2002. The zeros here are significant in this case. If there are no decimal points after the zeros, then the zero is non-significant. If there are no decimal point after the zero, if you don't have something like this, 200.0, this is significant. So if you have 200 like this, without this, the zeros here are non-significant. That's what this is saying. If there are no decimal point after the zeros, the zero is non-significant. The fourth one: every leading zeros is never significant. So when you have 002, these two are non-significant. If you have 0.2, these two are non-significant. Only this is the significant number that is there. So once you follow these rules, we are going to be fine with approximating numbers using the significant figure method. Now, let's get started with examples so that we'll be able to understand it much more better. Now we're going to be doing some examples to be able to help us understand. So example 1. Example 1. We are having 2, 3, 4. How many significant figures in 2, 3, 4? Now, the first rule, it says that every non-zero number is a significant figure. Every non-zero number. These are non-zero numbers, so all of them are significant. So we say 1, 2, 3. So we have 3 significant figure in this first one. Now let's go to example 2. In our example 2, we have 2113. We are asked how many significant figures are in 2113. According to the first rule, every non-zero number is a significant figure. So all these are significant figures. So 1, 2, 3, 4. So this is 4 significant figure. I hope we are getting it. Now, example 3. Example 3. Example 3. We're having 205. How many significant figures are in 205? Now, according to our second rule, it says that every zero in between two significant numbers, which means non-zeros, a number contains non-zero. So every zero in between two significant numbers is also a significant figure. So we're having 205. 1, 2, 3. So here we're having 3 significant figure. Every zero in between two significant figure is a significant figure. So since it's in between two significant figures, 0 is a significant figure in this case. Now let's go to example 4. Example 4, we're giving 2007. Now, how many significant figures are in 2007? As earlier stated, like example 3, every zeros in between two significant figure, 27, the zero is also significant. So we're having 1, 2, 3, 4. It's 4 significant figure. I hope we're all getting it. Let's go to another example. Example 5. In example 5, we're giving 200. Now, how many significant figures are in this? As we have earlier stated, the third rule says that if there are no decimal points after the 0, then the 0 is non-significant. Is there a decimal point here? No. So that means these zeros are non-significant. Non-significant. Therefore, we only have one significant figure here. One significant figure. I hope we're all getting it. So let's go to example 6 now. Example 6. Now, we're giving example 6. We are giving 200 with a decimal point. Now, in this case, according to the third rule, say if there are no decimal points after the 0, then the 0 is non-significant. If there are no decimal point after the 0, so now there's a decimal point here, so we can say that this has 3 significant figure. Example 7. We are giving 200 with decimal point 0. So how many significant figures are in this? So because there's a decimal point there, all these are significant. So we say 1, 2, 3, 4. So we're having 4 significant figure. Now, example 8. We are giving 0.026. Now, according to the last rule I gave to you, I said leading zeros are never significant. So these two are non-significant. This is only a significant figure. So therefore here we have 2 significant figure. Let's go to example 9. In example 9, we are given 0.00051. Every leading zero is non-significant. So this leading zero is non-significant. This is the only significant figure here. So we have two significant figures in this case. Example 10. We are given 0.0002801. Now, leading zeros are non-significant. These ones are non-significant. Zeros in between two significant numbers is significant in this case. So this is significant. And zeros after decimal point is significant. So this also is significant. So here we are having 1, 2, 3, 4, 5. We are having 5 significant figures. Leading zeros are non-significant. Zero in between two significant numbers is significant. And if there is a decimal point, the zero after it, if there's a decimal point, is also significant. So this is how to determine significant and non-significant figure. Out of, if you are given a mathematical expression like this, you'll be able to determine how many significant figures are in them. So let's go to more examples to be able to help us understand it better. In a situation where you are given 7.3, okay, let's say example. Let's start from example 1 again. A fresh example 1. In a situation where you are given 7.393, no, sorry, 3.925, sorry, 3.925. Now look at it carefully. We are told to state this, to approximate in 4 significant figures. Approximate this to 4 significant figures. Now, to solve this, how many significant figures do we have here? We have 1, 2, 3, 4, 5. And they say 4, so we have 1, 2, 3, 4. Now, this is the 4th one we're looking at. Now, the number that we're about to discard, if 5 is greater than, if 5 is greater or equal to, he said then you will increase the previous number by 1. So if the number you're about to discard is 5, the number that you're about to discard, number that you are about to discard. Now, when they say 4 significant figure, it means that 4 significant figure, which is 1, 2, 3, 4. So this is the 4 significant figure. Then you look at the next number after the 4th significant figure, which is 5. If the number you're about to discard is 5 or greater than 5, you say you will increase the previous number. This is the number we're about to discard. This is the number we're about to discard. So it's 5. Now, since this is 5, we're going to increase this number by 1. So this will be 7.393. This in 4 significant figure. I hope you're understanding it. So now, we're also told to approximate to 3 significant figure. Let's approximate this to 3 significant figure. 7.39. So wait, sorry, so that I will not mix things up. So we're able to see it clearly. So this is 4 significant figure. Now, let's approximate to 3 significant figure. Approximate to 3 significant figure. Now, as I've said, count the 3 significant figures. 1, 2, 3. This way it is. The number you're about to discard is the next number after 1, 2, 3. The next any number from the 1, 2, 3 is the numbers that we're about to discard, which in this case is 2. The next number that we're about to discard, like the number that we're about to discard, the next number that precedes that is after the 3 significant figure 1, 2, 3, this which is 2 in this case. Which condition does it satisfy? This condition 1 and condition 2. So now this satisfies condition 2 because 2 is less than 5. Leave the previous number the same way. So to approximate this, we'll say 7.39 in 3 significant figure. I hope we are understanding this. Now, as I've explained earlier, 3 significant figure 1, 2, 3. Which one is the next number? 2. This is the beginning of the number we're about to discard. Now, we'll check the conditions. Which of these conditions does this satisfy? It satisfies condition 2. If 5 is less than, so 2 is less than 5. So we'll leave the previous number the same way. So that's how we got this. I hope we understand it. So in a situation where we are saying approximate to 2 significant figure. Okay, we have to 2 significant figure now. As I've earlier said, count 2, since it's 2 significant figure, 1, 2. 1, 2. Now the number that we're about to discard, this is the second one. Number we're about to discard is this, 9. About to discard any number from 9 upward. Then looking at it, which of the condition does it satisfy? It satisfies condition 1. So, which means the number is greater than 5. It's either 5 or greater than 5. So it's greater than 5 because it's 9. 9 is greater than 5. You say you increase the previous number by 1. So this will be 7 point, increase the previous number, which is 0.3, increase it by 1, which is 7.4. So this out approximates to 2 significant figure, 3 significant figure, 4 significant figure, even to 1 significant figure. So this is how to go about it. Now, let's do another example so that we'll be able to understand better. We are given 14384. They said we shall approximate to 4 significant figure. Now, in this number, We have many significant figure. 1, 2, 3, 4, 5. We have 5 significant figure. We'll count 4. 1, 2, 3, 4. 4. So this is it. Now, the number that follows the fourth one, which is 4 here. Which of these conditions does it meet? Is the second condition, which states that if the number that you're about to discard is less than 5, leave the previous number the same way. So we're going to say 1, 4, 3, 8. So this is the fourth significant figure. I hope we are understanding it. So then we can add 0 here. But this is fourth significant figure. Because this 0 in this case, if you add 0, it's not significant. So there's no even need, but you can add 0, but there's no need. This is fourth significant figure. So now let's approximate. So we should approximate to 2 significant figures as well. To 2 significant figure. Approximate to 2 significant figure. We're going to count 1, 2. Now, the number that follows the second one, which is 3, which of the conditions does it satisfy? 3 is less than 5. So we have to leave the previous number the same way. So in this case, we are going to have 14. $14,000. We're going to put the remaining to 0. Sorry for the previous example, we need to put it to 0 because these are numbers. These are numbers, not going to make sense. So approximate it to the nearest number. So we're going to put the 0. We're going to put the 0 because there's no decimal in between. Correct that the previous example, or we can resolve the previous example so that we'll be able to understand it. Since I made a mistake there. So we're approximating to 4 significant figure. As I've said, for significant figure like this, what you're going to do, count 1, 2, 3, 4. This is the fourth one. This is less than 5, so this will be approximated to 0. If it's less than 5, we approximate to 0. If it's greater than 5, we are going to increase by 1, the previous by 1. Then if it's less than 5, we're going to approximate every number after it to 0. So this is 14380. So this is the correct answer. So you correct that. So you need to approximate this to 0 because it's less than 5. So it will be 14380. So to 2 significant figure, what you are going to do, 1, 2. The number that precedes it is 3. 3 is less than 5. So we should leave the same way it was previously, the previous number, 1, 4. Then approximate all this to 0, 0, 0, 0. I hope we are understanding this. It's only in the case of decimal that you don't need to put the 0 when you approximate to the nearest number. Now, let's take another example. We're having 0.0887, but approximate this to 2 significant figure. Approximate. Now, I told you every number that, according to the last rule I gave to you, I said leading zeros are non-significant. So these are non-significant number. So now we have to approximate this to 2 significant figures. So we'll start counting from here. 1, 2. So this 2 significant. This is the second one. 1, 2. Then the number that precedes it is 7. Which of the condition that the number that this number satisfied. It satisfied the condition number 1, which says that if the number that you're about to discard is 5 or greater than 5, then you increase the previous one by 1. So you increase this one by 1. So we are going to be having 0.089. This to 2 significant figure. You check 1, 2. The number that precedes it, 7. Which of the condition, the number that you're about to discard is greater or equals to 5. So this is greater than 5. The number is greater than 5. Then you increase the previous one by 1. So this 8 increases by 1. Add 1 to it, that will be 9. So that's how we got 0.089. I hope you're understanding it. So now we're told that we should approximate it to 1 significant figure. 1 significant figure. Now, looking at this carefully, the leading zeros are non-significant in this case. 1, so we'll count 1, 1. This is where the arrow should be. 1 significant figure. Now, the number that precedes this 1 is 8. 8 is greater than 5, so it needs condition 1. So you need to increase this by 1. So we are going to be having 0.09 in this case. 0.09 to 1 significant figure. So I hope we are understanding this. Now we're going to take another example again. So now, to convert this to 5 significant figure, what do you need to do? First, you count 1, 2, 3, 4, 5. Now this is 5. Then you look at the number you're about to discard. This 4. 4 is less than 5 according to our theorem that we stated there. The rule that we stated. 4 is less than 5, right? So since it's less than 5, this automatically is 0. So now to approximate to 5 significant figures, that will be 29.8000. Now we are not increasing this because it's less than 5. So that's how to approximate to 5 significant figure. We also thought that we should convert this same number, 29.8604, to 3 significant figure. So as said earlier, count 1, 2, 3. So this 3. This. Look at the number that we're about to discard. This 6 is greater than 5. So since 6 is greater than 5, it's because the rule states that if the number that we're about to discard is 5 or greater than 5, then we'll increase the previous number by 1. So we're just going to do this 29.9. Then all this will be 0, 0, 0. Let me write it properly. So this will be 29.9. This one will be increased by 1 because this is 6, which is greater than 5. So we increase the previous number by 1. That's 8 will go to become 9. Then all this one will be 0, 0, 0. I hope we all understand this. So now let's go to others. Now we're going to look at addition of significant figures. In a situation where you're given 1.58 plus 13.2. 1.58 plus 13.2. Now, The rule for this says that determine, to be able to add or subtract. We're going to go to this, come to the subtraction to aspect as well. Going to add, the rule says that determine the least, determine the least, the least, determine the least, the minimum, like the lowest. So determine the lowest, let me use that term, lowest number of significant figure. So that's what we're going to get, that's what our answer is going to be in. This now, this has 3 significant figure. This also has 3 significant figure. So the least here is 3 significant figure. So now when we add this together, we're going to get 14.78. You press your calculator. So now, since it's 3 significant figure, let's look at 1, 2, 3. So this is it. We'll look at the next number. This 8. 8 is greater than 5, which the rule states that if the number is greater than 5 or equals to 5, we should increase the previous number by 1. So since 8 is greater than 5, we're going to increase this one by 1. So we're going to be getting 14 point. This one increased by 1, 14.8. So this is how it's going to be done. Now let's do another example so that we can get ourselves familiar with it. So as I've said, determine the least. So it's, see, because this one is 3 significant figure, 3 significant figure, so we approximate it to 3 significant figure. That's how we got our answer. So let's do another example. In a situation where we're giving example, in a situation where we're giving 2.201 plus 16 plus 7.22. Now, when we add all this together, if you add all this together, we're going to get 25.421. That's what we're going to get. Now, how do we determine the number of significant figure that we're going to round it up to? First, look at it. Which one has the least significant figure? This one has 4 significant figure. This one has 2. And this one has 3 significant figure. Now, I said determine the lowest number of significant figure. That's where we're going to get our answer, the lowest. So the lowest here is 16. Because it has 2 significant figure. So that means our answer must be in 2 significant figure, which means that 25.4. So 1, 2. The arrow is here. The one we have to discard is anything from here, from 4. Now, is 4 less than 5? Yes, 4 is less than 5. 4 is not greater than 5, it's less than 5. So since 4 is less than 5, we approximate this to 0 or do not. So we are not going to touch the previous number. We are not going to touch it. So this is approximately 25. I hope we are all getting it. So that's how to do the addition. That's how we got 25. So as I've said, look at what you're adding up together. Look at that significant figure. This is 4 significant figure. This is 2 significant figure. This is 3 significant figure. Now the least of them is this, because it's 2 significant figure. So you round up your answer to 2 significant figure. Now let's do subtraction. Subtraction of significant figures. Subtraction of significant figure. In a situation where you're given 2.161 minus 1.0, still pretty much the same way as addition, similar to that of addition. So what we're going to do first is, now when we subtract this, when you subtract 1 from this, we're going to get 1.161. 2.161, if you subtract 1 from it, you're going to get this. Now this one has two significant figures, this one has four significant figures. Now look at it carefully. Which one is the lowest? Is the one with two significant figures. So which means that our answer should be in two significant figures. Now 2, 1, 2, these two. This number we're about to discard. This number we're about to discard now. From here, now 6 is greater than 5. And the rule says that if 6 is greater than 5, if 6 is greater than 5, then we should increase the previous number, the number before it, by 1. So which that will be 1.2. The other has to be 0, 0, which is equal to 1.2. That's how to subtract significant figure. So as I've said earlier, look at the number of significant figures that you have in the subtraction. This one has two significant figures, this one has four significant figures. So now you take the lowest, which is two significant figures. Now 2, 1, 2, 1, 2, 1, 2. This the two significant figure. Now the one that's following it is 6. 6 is greater than 5. It says, the rule says that we should increase the previous one by 1. So that's how we increase that. That's how we go to our 1.2. Now let's go to multiplication of significant figure. Multiplication of significant figure. Multiplication of significant figure. Now we're given 2.1 multiplied by 7.27. Now let's look at this example carefully. Now this one has two significant figures. This has three significant figures. Now looking at it, three significant figures. Now if you multiply 2.1 multiplied by 7.27, we are going to get 15.267. 15.267, that's what we're going to get. Now we're going to take the one with the lowest significant figure, this one, two significant figures. So we're going to approximate this to two significant figures, which means 1, 2, and the arrow is here. The one that we're about to discard, this we're about to discard, is less than 5. And we know that once it's less than 5, we're going to round it up to 0. So I'm not going to touch the previous one. So this will be 15.000, which is also equal to 15. Now let's do that of the division. The division. In a situation where you are given 84.121 divided by 2.112, division of significant figure. You are given this now, for example. When you press your calculator, you're going to get 39.83001894. Now, once you get this answer, as I've said, look at the number of significant figure. This one has 4 significant figure. This one has 5 significant figure. So we're going to make our answer 4 significant, the lowest. As I said, determine the lowest number of significant figure. So the lowest, which is 4. So we're going to do 1, 2, 3, 4. Now, the ones that I'm about to discard, the one that comes after the significant figure is 0. 0 is less than 5. And we said that once the number is less than 5, we should not tamper with the previous number, and we should round them to 0. So we're going to be having 39.83. So it's as simple as that. Decimal. It's using decimal places. Decimal. Another way to approximate numbers. Imagine you're giving 0.0493, and they say approximate to 3 decimal place. What's 3 decimal place? 1, 2, 3. You look at the number. This 3, as I've said. 3 is less than 5, as we said. 3 is less than 5. So this one will be 0 automatically. So we're going to be having 0.049. This is using decimal place. Now, if I say approximate to 2 decimal place, 2 decimal place, how do we go about it? Same thing, having 0.0493, just 1, 2. The number that precedes it, that's after it, is 9. 9 is greater than 5, according to our condition. 9 is greater than 5, which means that increase the previous one by 1. So we're going to be having 0.05. So this is how to use decimal place to approximate numbers. So you are given 11.273, a total approximated to the nearest to 2 decimal place. Approximate to 2 decimal place. How do you do this? As I've said, count 1, 2. The number that comes after that is 3. 3 is less than 5, which means that we should convert it to 0 or do nothing. So we're going to have 27. So we are told also to convert to 1 decimal place. This same question, approximate. We're told to approximate to 1 decimal place. Approximate to 1 decimal place. To approximate to one decimal place, you just do 1. That's all. 7 that comes after it, 7 that comes after it is greater than 5, which means increase the previous one by 1. So we'll be having 11.3. So that's how to approximate numbers. I hope you're able to gain 1 or 2 things from this tutorial. And I'm going to give you some exercises that you can solve on your own. And you're going to tell me your answers in the comment section below. Just try to attempt it. I'll see your answers and I'll know that you really enjoyed the tutorial, and then I'll reply your comment. So solve this, let me know your answers in the comment section. Don't forget, put your answer in the comment section. I'll be glad to see it and to know that you got the tutorial, like you understand the tutorial. So exercise 1, 22.3. Oh, sorry. Two, 3, 4th one, 5th one, 'So these are the exercises for you. Try as much as possible to solve it. It's very easy. Just follow the same principle. As I've always said, look at the number of significant figure to be able to analyze your answer. Like this one first, how many significant, which one has the least number of significant figure here? Is this, and we have only 2, because all these zeros are, they're non-significant. Leading zeros are non-significant. So you have 2 here. So these 2, once you multiply it, you convert to 2 significant figure. And as I've told you, you use the same principle that I've explained to you to do that. If the number that precedes your after you count 1, 2, the number that precedes it is greater or less than 5, then from there you'll be able to analyze, maybe you are going to increase the previous one by 1, or you are going to do nothing or just add 0 to it. Thank you. If you find this tutorial really helpful, please don't forget to like, comment, and share.